Hello friends. Today in today's session we'll learn about multiple regression model, multiple variable regression model, and we're going to express that in terms of matrices. So this is basically the advanced econometrics level. So this we'll be continuing this series actually. So if you have studied the basic econometrics of Gujarati earlier, then this will be very good. You will have very good edge over others in advanced econometrics. And second thing, if you have mathematical background also, or if you even if you don't have mathematical background, you can study the matrices determinants. There are a lot of videos available on YouTube, and within a few days you will be quite proficient in matrices. So this multiple regression model that we'll be studying, generally we keep the three variable model, vari three variable, that means independent variables two independent variables and one dependent variable. Okay, so this is three variable model. So this is the minimum that we had as a multiple regression model. But what about if you have k number of variable? Okay, so this was three variable model, the simplest one, three variable model. We considered this as multiple linear regression model, but in econometrics, as econometricians, mm, they have to deal with many variables. So in that case, you'll be dealing with, suppose, k variable. Okay, we don't know what that number is. So in case of k variable model, that is the more than these three variables, any number can be k variable uh, multiple regression. Then what you are going to do in such cases, you have to apply the matrices, and matrices actually it makes easy to explain them. Okay, so if there is a k minus 1 independent variable will be there. Okay, independent variable will be there. Okay, let's write this PRF, that is population regression function, that is the yi, okay, is equal to beta 1, okay, plus beta 2 x2 x2i plus beta 3 x3i. Okay, and likewise it continues till beta k and xki. Are you getting me? Okay, plus there will be error term. So this ey is the disturbance term because it actually disturbs the stable relationship. So what is that stable relationship? That is beta 1 to till this part. This is the stable relationship, or this is also known as the deterministic relation, and this ey is our actual the random. This is because maybe we have omitted some values, some variables in this model. So their positive or negative impact will be just average out in this ui. So that is the net effect actually. Okay, and this is k variable model. So that means we are having k minus 1 independent variable, and this remember this beta 1 is not having any x um, along with it. So that means it is having actually k minus 1 independent variable as independent variable. Okay, and one dependent variable, that is yi. So in one way we can put this I value, that is the number of observation, is from 1 to n. Okay, 1 2 3 4 to n. Okay, so if you want to write, if you extend this equation, then you can just write it in this way, that our y1 will be your y1 in this place you are just putting the 1. Okay, so the first one will be y1 equal to beta 1 plus beta 2 x2 1, okay, plus beta 3 x3 1, okay, and so it continues till beta k x xk n, right? Sorry, xk1, sorry, because this is for y1. So this is beta k xk 1 plus u1. Okay, so this is one. Then you are going to write it for the second one, second observation, that is beta 1 plus beta 2. Here which part we are going to change? You are going to change this part. Okay, this part you are going to change. So beta 2 x2 2 plus beta 3 x3 2 plus beta k xk 2, okay, plus u2. Alright, and it will continue till when? It will continue till the number of observation is n. Okay, so this part 1 2, that is yn. Okay, so that is beta 1 plus beta 2 x and oh sorry, this will be 2n, beta 2 x 2n plus beta 3 x3n plus, and it goes to beta k x k n plus un. Okay, so it will continue till this point. And now how you are going to write them in the matrices format? Now that you have got so much simultaneous equations, these are known as simultaneous equations, and you can express this in terms of the matrices. So you can see that this portion, this is y1 to yn, this can be a column vector, right? Okay, so you can write it as y1 y2 to yn. Okay, this is one part. Now you are going to put the x1s. Okay, but remember your beta 1 here is a constant over here. Okay, in order to accommodate that, what you are going to do is in this x matrix, so how you are going to write the x matrix? Actually, you are putting x21 x31 till xk1 first row. Similar this one, x22 x32 till xk2 in the second row, likewise. Okay, let me put that. So x21 x31, and it will go till xk1. Okay, so this is the number of variables, k is the number of variables, and n is the number of observations. Remember that. So this one is x22, and it goes till xn, x2n, x2n. Similarly, this is x32, and this will go till x3n. Okay, and this will go till, this is xk2, and this is xkn. Okay, and here you are putting the 1 as constant. Okay, because why it is so? Because the beta 1 is constant at all this point, and this will be multiplied by beta 1 beta 2 to beta k. Okay, so till this beta k, this parameter. Okay, and then you're putting this error terms. So this is u1, u2 to un. Okay, now if you want to establish the relationship between them, you can just write the equation, that is this one, this dependent variable y1 y2 till yn will be equal to this is n into one matrix, that is n is the number of rows and 1 is the column number of columns. Okay, so this is n times 1, that is n rows and 1 column. Similarly, this X matrix, this is n into k. Okay, n into k, so n row and k column. And then you're having here, this is k into 1 and this is n into 1, n row 1 column, k row 1 column. Okay, so y is n times 1 column vector and x is n times k matrix, giving on n observations on k minus 1 variables. Okay, and this 1 1 1 actually this is representing the beta 1, that is the constant one. Okay, and so if you are going to write it simple, right, so it will be y equal to x beta plus mu, where your y equal to n times 1 matrix and x is your n into k, beta is your k into 1, okay, and u is n into 1. So you can simply write it, you can simply also write it y equal to x times beta plus u. Okay, so this is the simplest format to write any number of observation or variable. Okay, so this is how you show the multiple variable regression model in terms of matrices. We'll solve few questions in the next video. Okay, thank you for watching.